Hello and welcome to the Tetration video series. My name is Rob and I'm here with Remi, and in this module we're going to talk to agent configuration. So Remi, through some of the other modules that we've had in the series, we've talked about the different agent types that we've got in the system and the way that they actually bring telemetry and other sources of data into the platform. But of course, just deploying an agent's not really enough for us to really gain full control over it. So of course we need to do some configuration.
Does that mean it's CLI time?
Unfortunately not, as much as I know you'd love to just sort of go deep into that. Most of the operations, as we'll see again in a different module, and the actual agent configuration, we can actually do directly through the user interface.
That's somewhat disappointing, Rob.
It is disappointing.
I was hoping to put some Ansible correlated with lots of shell script and stuff like that to get it to work, but no?
No. So let's get started with the configuration. So up in the top right corner, we've got our little gears icon, and down below we've got agent config. That seems to be the right place that we should go.
I see a little key next to agent config. Does that mean that it needs special rights?
It does need special rights, Remi. That is a very good point. So different levels of control applied through roles in the system. So in our section around RBAC, then we'll cover that in more detail in terms of the different roles and how they can be applied across different users. But certainly this is an area of the platform where you certainly do want to have an appropriate degree of control to be able to configure the agents that are deployed.
I would agree on that, definitely.
Yep. So what you see on the screen here are really two key parts. So on the left side, we've got the individual configurations. And then on the right side are how we actually take the configuration and we apply it to a set of agents. Sounds pretty straightforward.
It's called profile. So there I define behavior, but if I define it here, nothing happens until I actually apply it on the right side.
That's correct. Yeah. So the whole idea of the intent is to take the profile that you've configured with a set of configuration options that you decide you want to apply, and you configure them in an intent which then applies it directly through to the workloads.
So does that mean I have to structure my scopes in a specific way for that to work, or can I use filters?
You can, so when we actually get into this, you'll see we can use filters. So you've got very flexible ways that you can actually deploy the agents to make sure that you target the agents appropriately.
Okay, so I don't need to think about my scope structure, in regards to this. That doesn't matter.
No, it's completely independent.
I like that.
Yep. So let's take a look at the configuration profile to start with.
Should we start by the default one, actually? Because that one seems to be modified.
So by default, when Tetration is deployed, it comes with a default set of configuration and a default intent. And the intent is to apply the default configuration to everything. Okay, so this is where we start. And you can see here that it's actually broken into three separate components. So we've got configuration settings that are specific to the enforcement capabilities, configuration settings for visibility, and a separate component for forensics. So three key capability sets of the agents that are deployed in the workloads.
So you just mentioned something that this applies to everything, right? Yep. So if I don't create any intents, this will apply first.
Correct.
Would you recommend you make any changes there, or should you always create a sort of copy of this before making any changes?
I certainly recommend that you start with the default and then work out what you would like to modify beyond that. Because as we kind of step through some of these settings, you'll see certain areas that maybe you do want to adjust. But out of the box, I think they're actually pretty sound.
Okay. Yeah. So in most of the cases, maybe except for the enforcement one, all the others should be okay.
Yeah, because it'll get started. And I guess step one with the agents is let's get some visibility. And if you look at the other settings, we've got forensics is disabled and enforcement is disabled with the default settings. So really the intention of the default is to be able to just start bringing data into the platform.
Okay.
And then beyond that, then you can choose to add on additional capabilities as and when you're ready.
Okay, sounds good.
Okay. So maybe let's start with the visibility component here, because really the idea is that we want to, from the point of having the agent deployed, we want to start ingesting that telemetry.
Yeah,
okay.
Let's look at that.
So the first one there, data plane. Remi, do you want to just give a quick explanation as to what that is going to do?
That's a fancy name to start with.
It is.
My understanding of data plane, and you correct me if I'm wrong, but my understanding of data plane is that when you have a sensor, the sensor is actually going to send telemetry out, and the telemetry will go back to the cluster. In some cases, you might want to say, hey, this sensor there, I want to stop getting telemetry for it for a while because XYZ, maybe it's in maintenance, or whatever reason you can come to.
Yep.
What data plane does, it does not disable processing of telemetry on the host, it disables exporting of telemetry on the host. So you would still process all the packets, but no packets would get out anymore. They would actually just get discarded.
Okay.
That's what data plane does. When do we see that useful? Not often, to be honest. I remember one occurrence where we used it. The system was a monitoring platform, and the customer just basically wanted to test what happens on this monitoring platform. Yep. He deploys an agent, he enables data plane, telemetry comes back, he looks what he wants to look at, and then shuts it off, and so on, but doesn't remove the agent.
So I guess it's another just form of control to enable or disable the telemetry stream coming into tetration.
Exactly.
Yep. Okay, and because we always want to make sure that the agent itself continues to operate and is checking in, and we've got the monitoring, which again we'll cover more in the operations module.
Yeah.
Now, once we've got telemetry coming in, we've also got life cycle of the agent to consider.
Yeah.
And this is as we go from the initial deployment on a specific version, the platform is going to go through subsequent upgrades.
Oh, Ansible. No, still no Ansible?
No Ansible just yet, because part of the operation of the agent, and again, we're trying to take care of the life cycling. There's probably a couple of key components to talk to here that are seen as, they certainly draw a lot of questions. How do I maintain and operate this over its life cycle? We don't want to have to, be modifying and upgrading individual agents at scale over thousands or tens of thousands of agents. So auto upgrade is the ability to let tetration handle the upgrade process for you. So as the cluster is upgraded, so tetration itself gets upgraded from the current release to the next release, auto upgrade enables tetration then to lift the level to perform an automatic upgrade of the agents so that they then come up to a matching level.
I see. So if I understood right, if I look at the bottom of the page, I see the version 3322.
Yep.
So if I was to go from 3322 to 3323, maybe, lots of trees there. If I were to do that, you're saying that my agents currently running 3322 would actually automatically get to 3323.
That is correct.
And I don't need Ansible?
You don't need Ansible, no.
For Tim, System Center maybe.
No, let's kind of keep
really
that out of it right now. But for this process, for the upgrade, it can be handled within the platform. Okay, and this again is something that can be enabled or disabled. And there may be cases where you might want to disable this to control the versioning, and then to use it perhaps to enable upgrade as and when you want the upgrade to occur. I
see. So maybe customers that are under very strong change management, they might want to disable that, and then basically just enable or manually upgrade if needed in the future.
That's right. So there are different ways.
You can use Ansible then.
Let the Ansible go. There are different ways that we can upgrade the agents. Auto upgrade is one of those. There is also an upgrade workflow that enables us to actually do it on a more on-demand basis. Okay.
I see.
But again, options to enable, disable, choice for the customer to take control in whatever manner works for them.
And my understanding is that if I disable that and have sensors, for example, go into 3323, let's say right now, let's say we're running 3322, and the cluster has some agents deployed in 2.3 for some reason.
Yep.
If I am to flip the auto upgrade on, the upgrade will start immediately for the 2.3 agents. That's my understanding. Is that correct?
It's not immediate.
It's not immediate.
So there is a timing associated with those, so they don't all it's not a matter of all agents that are of a particular release get upgraded at the same time. So it's more of a sort of rolling update that takes place, so that we see them upgraded over time according to the timers.
Okay, I see. Is that linked to the thing called like the check-in time and stuff like that?
It is. It is.
Okay.
Now that's something that we'll also discuss in the agent operations module.
Okay. Cool. So this feature is enabled by default. I guess our recommendation is leave it on if you can.
Yes. Again, in terms of life cycling of the agents, what we certainly want to avoid is the case where the cluster itself continues to get upgraded and we just let the agents stay on the older releases. We want to maintain that the agents themselves are brought up to the level of the tetration cluster. And so we just sort of have that alignment so that we don't end up with a massive drift of versioning. Okay.
I believe, if I understood correctly, our support policy is like N-1 is a support policy for agents.
Yeah.
So you should keep them within one release of each other?
That's right.
Okay.
Yep. So that way, again, it allows for the cluster itself to be upgraded and potentially for the customer to determine when is the appropriate time to upgrade the agents.
Okay.
So then we bring them up. And again, that can be done in waves. You can define how you actually want to bring those up so that you're not adding any sort of undue process there.
Okay, sounds good.
Now, next
PID lookup.
Next on the list is PID lookup. Now, we've talked about different data points coming into tetration. Telemetry, the data plane, flow telemetry coming in, but we also get process information, right?
I saw this process information coming in. I saw some process data in ADM, some process in flow search. Mm-hmm. ADM, sorry, applications, and one in flow search. Is that different? How does that work?
So what PID lookup is doing is actually asking the agents themselves to associate the process information with the flows. So as we ingest flows into tetration, we get the PID, which again gives us the ability to have the process information aligned with the flows in flow search.
Okay, so if I don't enable that, I get process data on one side, I get flow data on the other side, but I don't have a correlation of flow to process.
That's right.
Okay, and that just basically just creates a link.
That's right.
Okay.
Yep. And you can see, again, that's disabled by default. Now, enabling that really does incur some additional processing on the agent, which is why by default it's disabled, but it does bring those two views together, which gives you a more comprehensive view in the flow output.
Would you see that as something that we would recommend turning on, or it's like nice to have, but doesn't actually bring tremendous value?
I personally think it's great value because it actually gives you that ability to look back in time at some sort of forensic event and to get more context around what was actually occurring at that time.
Okay.
So if I can see that a flow took place and the process that was behind that particular flow, I could understand what that was at that point in time, then that's certainly going to be helpful for trying to identify that particular issue.
Okay. My understanding as well that's more valid for long-lived flows. I mean, I guess we'll talk a bit more about that in the session regarding operations, but
that's right.
Is that right?
Yeah, so the nature of actually pulling those two data points together and attaching them to stream that data through, it's really going to apply for flows that just have a slightly longer lifespan, right? So typically flows over a minute, we'll see that process information come through.
I see. Sounds good.
So now we get into the overheads of the agent. And we'll see basically a similar combination appear across each of these three groups here. But let's just start in terms of visibility, because again, one of the common asks when we speak about agents with customers is, what are the overheads?
Yeah.
Yep.
Always probably number one question. Close to number one at least.
Yeah, it is, absolutely. Now, we can say things like it's a lightweight agent, it doesn't consume much resources, it's very optimized, but how does the customer know that's the case?
Oh, I heard that story from other vendors. It's a very lightweight agent.
That, right?
It's like on my 32-core system, it only consumes 0.01% of CPU. Yeah, I heard that story already. So yeah, okay. What do we do differently then?
Well, let's just talk about what we see on the screen here. We've got monitoring of the consumption of resources that we'll see again in the operations and monitoring module. But in monitoring those, we're also we've got the ability to set caps there, so that we actually define limits so that we won't exceed those limits. And we do that both in terms of CPU and memory. So CPU allows us to actually define a quota or a cap to make sure that the agent won't run wild and consume large amounts of resources. And that's a user-definable threshold. It's not simply a matter of saying yes or no to this 3%, so 3% CPU consumption by default. You can adjust that if you've got a specific set of demands.
So what we're saying there is like, yeah, okay, lots of people say they actually are lightweight agents, so we say we're lightweight agent, and we let you set a cap to make sure that we're actually really a lightweight agent. Is that fair? That's
right. Then the next question is, what happens if I hit the cap?
Yeah, exactly. What happens if I hit the cap?
Well, we sort of really need to consider both of these, CPU and memory. Now, if we're consuming too much memory, we'll simply restart this process that's actually performing that function in the agent. That lets us take a fresh start and avoid us actually, again, consuming excess resources there.
Oh, so you're saying if for some reason development had missed a memory leak or something like that, rather than just let it go through 64 gig of RAM and then let someone else figure that out, we just say, okay, if you cross this threshold 512, just restart the agent so we clear up the memory.
Yes, because we know in normal operation it just should never happen.
Okay.
Yep.
So do you think that's something someone should change on the system then?
Personally, I don't think so. I think the default itself is pretty good.
That's good. I like that. Less changes.
Yep. And then in the CPU model, so there's two parts there. One is a percentage, and the other is this term adjusted. And again, this is something that we will actually explore the options there, adjusted and beyond. But it allows us to actually define the appropriate model of monitoring the CPU consumption across the different cores or the resources in an actual workload itself, and make sure, again, we've got the right model that the customer understands and is appropriate to that particular environment.
Okay, see. What you mean is that if I had, for example, like very short, a system with 4 cores, I would get 400% of CPU, and so we're taking 3% out of 400, and that's adjusted. And I think the other mode is called top.
Yep.
And top would be, well, I have 4 cores, I take 1 core is 100%, and I take 3% of 1 core. In summary, that would be, we'll see that in more details, obviously, but...
That's right.
Okay.
Okay, so we've got the control over the base functions from visibility and the control over the resource consumption. So let's just step maybe towards the top here and have a look at enforcement.
And just to clarify, this behavior, this way we can get a bit of time free on the other ones, CPU quota mode and memory quota limit per feature acts in the exact same way, right?
That's right,
okay.
Exactly the same, yep. So let's take a look at some of the other settings on the enforcement. And the first one is enforcement enabled or disabled?
That sounds a very good question.
Yep. So by default, the enforcement is disabled. Now, that really forms part of the control point over the enforcement of policy that we actually have here. So one is the agent that's deployed a deep visibility agent, which has no enforcement capability, or is it an enforcement agent which does have the enforcement capability built in? Depending on the agents that is deployed, we then got a second layer here, which is the configuration of that agent. So another knob to determine whether enforcement is enabled or disabled. And again, the default is that is disabled.
Okay, I like that. So you're saying that I deploy a new agent is not yet assigned to something, so it falls into the default environment. So if someone messes up for some reason, he creates a rule that says, I don't know, deny any in the environment, and he enforces it, nothing will be impacted by default because this is disabled.
That's correct. There's sort of multiple safety levels built into the platform to make sure that there is no unexpected enforcement aspect for newly deployed agents.
Like that.
Yep.
Foolproof. Perfect.
Yes. So the next one, preserve rules. Now this is an interesting one in that the tetration enforcement policy is delivered through the host operating system native firewall. Now, what if there are existing rules? What if those firewalls are already in use? Or what if there is some other let's say, another orchestrator as an example that's controlling those firewall rules?
That's a great question. Yeah. What happens?
Well, this configuration setting really determines what is the outcome there. The goal of tetration is to take control of the operating system firewall. We want to be able to define the complete policy that we actually deliver and enforce on that agent. However, there may be exceptions to that. Now, Remi, can you think of one, I guess, common exception to that rule where we might really want to preserve rules?
I'm thinking, I see one we see every single time, Kubernetes. Kubernetes, in its network framework, tends to actually put IP table NAT rules inside the platform. So it actually doesn't create any enforcement rules, it creates NAT rules. If we don't have preserve rules enabled, we see, oh, someone is changing rules on the firewall. Wait, okay, let's revert them. And so we end up in a situation where Kubernetes reverses the rule, tetration reverses the rule, Kubernetes reverses tetration, and so on. It ends up in a loop. So preserve rules is, for any Kubernetes nodes, you should enable preserve rules, as a first example.
Yeah, and that's a primary example, right? Where we just want to avoid conflict and we just want to have a clean division of control, in our case for enforcement policy, and then maybe some other control for NAT or other parts of the IP tables.
Plus, if I remember, on top of that, preserve rules is actually fairly smart as a process, because if you remember the session regarding enforcement, we showed you the rules inside a sensor. And remember there was TA input and TA output were two names of chains inside there. What preserve rules does is basically you can change anything except those two. As long as you don't change those two, you're fine. Those two are managed by tetration. So it gives you quite a bit of flexibility at that point. Now, would we recommend that for something other than containers?
I would say no. Really, what we're trying to avoid is any conflicting control of security policy on the box. If we have different systems attempting to apply different forms of control, the whole idea of understanding the decisions that get made, the policy that's actually applied to particular flows, gets really hard to unravel, right?
I would agree to that. Plus, I mean, we have a saying in French. I don't know how well it translates to English. You can correct me, but you can't have two cooks in a kitchen.
No, that is fair. Yeah.
So, and that if you have two cooks, well, your food is going to be terrible.
Yes.
So that same applies here for tetration.
Yes, and this is something we actually covered to some extent in the policy analysis module, where we talked to how we can actually discover directly through the UI which policies are applying to particular sets of communications. So it's very easy to see what policy tetration is actually delivering there. And we want to make sure that that directly matches against what's configured on the workloads.
Sounds good.
Yep. The next three really kind of come together, right? So these are settings.
I see lots of swear words there. Broadcast, multicast, my God.
So most of the time when we're talking about policy, we're focusing on the application policies. We're talking about groups, talking to other groups that are delivering application services, shared services. Maybe it's other, InfoSec policies, etc. Most of the time, we're not really sort of thinking of the underlying principles, whether it's heartbeat networks or broadcast and multicast activities that happen, whether it's at the OS layer or as part of the implementation of a particular software package.
Database cluster controls.
Database cluster controls as a primary example there. So what we want to do is provide really simple means of control of those capabilities. So broadcast, multicast, and link local traffic really being the key examples of those that in most cases we want to just simply allow in the policy, but still provide control over to make sure that we handle those kinds of scenarios because they're not always obvious.
I see. So in short, if you turn on any of them, we just blanket approval for multicast, blanket approval for broadcast, blanket approval for link local.
That's correct. Yep.
And that's again per workload. So I would say probably if you have one of those databases, you pick the nodes which are needing this cluster control link, you put them into a specific group, and that's it. And then you allow for link local.
Correct. Yep, that's a fair approach.
So you said that's the default, by the way. The default.
That is the default.
Okay.
Yep.
So in most environments, I guess even default is probably okay in most of the cases.
Yeah, yep, should be okay. But again, I think it is those key examples where we want to make sure that we've got a form of safety there, so that if you were to deploy enforcement and you've got a very carefully crafted policy that you're deploying there, but you've maybe forgotten about the local multicast needs of that application, that it's going to be, we're not going to impact the application in doing so.
Sounds good.
So that really covers enforcement, awesome. Which then brings us to forensics.
2 out of 3. Let's go.
So this is another capability that is also disabled by default. Now, we'll cover forensics in more detail in the forensics module and give a lot more understanding about the different features and characteristics of that. But this is something that actually has options associated to it. So by, I guess, as an overall control, we can enable or disable forensics. But then there are some additional components in there, and we see, for instance, meltdown and this cleverly worded anomalous cache detection activity detection.
Those are fancy
That's
words.
A lot of words, yeah. That have an additional layer of control. Now, why would that be that we might want to enable them separately to the overall feature set?
So, first one is simple. Well, it's meltdown. Like, I think everyone heard about meltdown at this point. If not, just Google it. You'll see there's lots of documentation on that. And the second one, anomalous cache activity detection is actually Spectre. As an example of the attack. Those are type of attacks, let's put it like that. The problem to some extent is that Meltdown and Spectre, being more hardware involved, require a bit more resources to be able to process. And there's some cases where it doesn't matter if you want to look at Meltdown or Spectre. I'll give you an example. If you're running virtual machines is running in your infrastructure, and your hypervisor is patched from Meltdown and Spectre, well, actually, how much value is that bringing to you? Yeah, you can see someone trying, okay, fair. Is that worth the overhead in terms of CPU? Maybe, maybe not. That's your call at the end. So we're kind of mindful of that, and so we give you this option to say, oh, you know what? Yeah, if you care about it, do it. If you don't care about it, don't do it. In my opinion, those are well suited for VMs which have high exposure. So you take VMs that are in the DMZ, VMs that are in the cloud with a public-facing IP, those kind of stuff. I think those ones are prime candidate to put that. VMs running on hypervisors you don't own, so you're running on someone else's machine. Yep. You probably want to look at those kind of things.
So given that we're here just looking at the default settings, we don't need to turn this on for everybody, right? So we've got selective control. So we're able to take the default settings and we're able to actually create our own specific configuration profile or set of configuration profiles to give specific capabilities and apply those through intent to a specific group or different groups of workloads.
That's pretty nice, and that actually makes sense, because if you're telling me that I only have one profile and I have to switch between one or the other,
it's not going to work out so well. So in our environment here, we've created one additional configuration profile, the Acme configuration profile. And there's, compared to the defaults, probably the key one here is we've actually enabled enforcement, because part of our demonstrations in the different modules includes the actual enforcement of the policy.
I noticed, well, obviously, PID lookup, I'm guessing, is coming from you.
Yes, PID lookup too, yeah.
I noticed we disabled the CPU quota on our boxes. I'm guessing we just did that by habit.
I actually don't know.
I think it's one of those things. If you're running a single CPU on the machine, so obviously our environment is lots of VMs. We're a bit cheap as a team, so we just give one CPU per VM. If you run one vCPU per VM with one single core, CPU limit doesn't really make sense.
Okay.
So we just tend to remove it.
Yes.
That's what we did there. Obviously, I do not suggest you do that in production. That's a lab. It runs lots of VMs in one lab, but I do not do that in production.
Okay, understood. All right, so the creation of new profiles is really quite straightforward through the Create Profile button here. It will just basically bring us up a set of options which we can name, apply to a specific owner, and configure the settings within that.
And I see everything that's default has a clear explanation as default.
Exactly.
Okay.
Yep. And we've got the different options there for the CPU quota mode, as you introduced earlier, and then
Which we usually leave default, right?
just
anyway.
leave default on the adjusted. Yep. And then once we're done and we've configured all our settings, we hit save, and that's going to create us a new profile.
Okay.
Now I'm not going to do that for now because we've already got a couple of
created ours.
examples there. But what really comes next is how do we actually apply that? Okay, and the application of the configuration profile to a specific set of workloads is achieved through the profile intent, or the configuration intent, I should say.
That's right.
So what we see over the right-hand side here is what is already configured. And we have the default, which is non-configurable. That says we're going to take the profile default and apply that to everything. So everything has some configuration. You can adjust what that configuration is, but everything, when deployed, is going to automatically pick up a default config. Above that, we've now got the ability to apply additional intents and to order those intents as well. So this is something we can adjust the order of if we wanted to order in a particular fashion.
Okay. Do you know any use cases where you would change the ordering, top of your mind?
Well, I guess one example is that you might have a specific configuration you want to apply to a particular environment, but then within that environment you want to even have even more granular set of configurations. So, a particular application environment gets a specific configuration, but then just the Windows machines in there, you want to apply additional set of rules, and that you can then be more targeted. So you've got different levels of granularity you can apply.
Oh, I see. So, for example, I could have a scope on which I apply a policy, and then within that scope, I could apply a filter to some subset of machines.
Exactly.
Okay, that's the ordering. Makes sense.
So let's have a look at how we actually create an intent. Now, over on the left, we've got our configuration profiles configured, and at the moment, we've got one called Acme. So we
Auto-populate.
Yes, we can auto-populate based on what is already configured, and that will give us the ability to define the profile.
I'm still happy with my lazy bear approach. I think you forgot to click on the list.
Yes, I did. There we go. So Acme is now set, and in the filter space, now we get to define which either scope or filter we want to apply the policy to.
Okay. If I don't see any scope or filters I like, what do I do?
If you don't see any scope or filter you like, you have the ability to create a new filter.
Okay.
And here's where you can create one, again, with the specific set of attributes they actually want to filter down to. So based on what Tetration knows about, we can filter any of those and any combination of those to be very specific or quite broad depending on what we need to define.
Could you show me how I would apply that to all Windows workloads, for example?
Sure. Let's just create a new filter, shall we?
Okay. Let's go.
So we're just going to call this...
Call it Tim's filter.
Tim's filter.
I know he's a big fan of Windows.
All right. So we want to match this. So we're going to filter against the OS. And if I recall the query, let's just say contains...
MS, I think?
MS.
Oh, there's one inventory item. That seems to look good. I think we have one Windows.
We got one. That's lucky, isn't it?
You can see the impact of Tim on our environment.
Well, that's as simple as that. So I guess, further to that, you could even target specific versions. So maybe you just want Server 2016 as an example, and then you just complete this, say, MS Server 2016.
Okay.
And you basically match the attributes that you've got. In this case, the OS being reported by the agent directly into the inventory.
Cool. So now I didn't press save. That's all I need to do.
Well, let's just take a look at, so one, we know that there is one particular machine that we've matched to. We'll just leave that for now because we know we've got that one Windows machine.
Yeah.
We've got which scope do we want to apply this to, which in this case is our root scope.
Perfect.
So this is going to apply to everything and basically filter every Windows machine into our environment into one group. So we'll accept that. And now if we just match on Tim's filter and save, we've now got a specific set of configuration, although in this case we've just applied Acme. We could have had an Acme Windows profile that we wanted to apply to Tim's filter or to all our Windows machines, and we've now applied it.
Okay. Very cool. So that's how I configure, that's how I apply, and that's it.
That's correct, yeah. It's two steps, very simple.
That seems simple, I like that.
Okay. So that concludes this module on agent configuration. For more detail, please go to cisco.com/go/tetration. Thank you.